Welcome to the Automated Daily Space News Edition, the podcast created by generative AI. Today, the story of space is one of momentum everywhere at once, auroras over Earth, astronauts repairing orbiting infrastructure, rockets feeding a growing orbital economy, fresh scars on the moon, and discoveries that are rewriting what we thought we knew about planets, galaxies, and even black holes. Let's get into the latest from August 20, 2026. This episode is brought to you by Lindy. Lindy is your ultimate AI assistant that proactively manages your inbox, meetings, and calendar so you can focus on what actually matters. Find the link in the episode notes. We begin close to home, where the sun has been stirring up Earth's magnetic environment. A pair of geomagnetic storms kept auroras glowing across high northern latitudes, a beautiful reminder that space weather is both a spectacle and a systems challenge for satellites, communications, and power infrastructure. August has also been packed with skywatching milestones, including the recent Perseids meteor shower and total solar eclipse, with a deep, partial lunar eclipse still ahead later in the month, giving astronomers and the public plenty of reasons to keep looking up. On the International Space Station, NASA astronaut Anil Mignon and ESA astronaut Sophie Adenauer completed a more than 6-hour spacewalk to remove a failed high-speed space-to-ground antenna from the Z1 truss. The job proved tougher than expected, with stubborn cables and fasteners slowing the timeline enough that the planned installation of the replacement antenna had to be postponed. Even so, station communications remained secure thanks to redundant systems, and the EVA marked a milestone for Adenauer as the first French woman to conduct a spacewalk. A day later, the Expedition 75 crew pivoted from exterior repairs to recovery and research. The astronauts refilled suit cooling water, powered down equipment, stowed tools, and prepared for a likely follow-up EVA later in August to install the new antenna. At the same time, station science continued, with work tied to circulation and microgravity, artificial intelligence applications, and Earth photography, reinforcing the ISS role as both an orbiting laboratory and a complex piece of infrastructure that constantly needs care. Launch activity remains relentless. Rocket Lab prepared an Electron mission from New Zealand, carrying a synthetic aperture radar satellite for Japan's IQPS, part of a growing commercial push to provide all-weather Earth imaging for disaster response, infrastructure monitoring, and maritime awareness. Meanwhile, SpaceX kept up its routine but still remarkable Starlink deployment pace, with another Falcon 9 mission scheduled to loft 29 broadband satellites. Taken together with broader 2026 launch statistics, these missions show how access to orbit is becoming faster, more commercial, and more tightly linked to services back on Earth. Around the moon, NASA's Lunar Reconnaissance Orbiter spotted a fresh impact crater created when a Falcon 9 upper stage struck the lunar surface on August 5. That upper stage had been linked to the earlier Firefly Blue Ghost 1 mission, and the new before and after imagery gives scientists a rare calibration point for impact physics with a known human-made object. It also raises a bigger issue. The moon is no longer just a natural archive of solar system history, but increasingly a place where human hardware leaves permanent marks. That matters even more because lunar traffic is only expected to increase. China's Chang'e 7 mission is targeting the South Polar region, while NASA-backed commercial lunar missions like IM-3, Griffin Mission 1, and Blue Ghost Mission 2 are lining up their own objectives. The lunar South Pole, with its possible water ice and strategic value, is rapidly becoming one of the busiest destinations beyond Earth orbit, making questions of coordination, contamination, and long-term stewardship much harder to ignore. In exoplanet science, one of the standout discoveries is GJ53b, a planet about 2.5 times Earth's diameter, but roughly 23 times Earth's mass. That density suggests a rocky world at a scale where many formation models would expect a thick gas envelope, making it an apparent mega-Earth and a challenge to standard ideas about how planets grow and retain atmospheres. It's the kind of outlier that forces theorists to revisit assumptions about core accretion, atmospheric loss, and the boundary between super-Earths and mini-Neptunes. Reuben Observatory data have also produced Aquarius IV, a probable ultra-faint satellite of the Milky Way about 355,000 light-years away. If confirmed as a dwarf galaxy rather than a diffuse star cluster, it would rank among the faintest known companions of our galaxy and offer an important test case for dark matter models and the fossil record of the early universe. Even before full LSST operations, Reuben is already showing how transformative wide, deep surveys will be for mapping the hidden architecture of the Milky Way halo. And then there are the discoveries that sound almost like science fiction. researchers have reported a possible new class of object dubbed a black hole star, something apparently powered by a central black hole yet resembling an enormous stellar body on larger scales. If that interpretation holds up, it could open a new window on how black holes grew rapidly in the early universe and challenge the tidy categories astronomers have long used to separate stars, compact objects, and galaxies. The James Webb Space Telescope is also continuing to push the frontier. A galaxy known as JADES, GSZ 13-1, seen when the universe was only about 330 million years old, has shown strong Lyman alpha emission, which is surprising because the intergalactic medium at that time should have been mostly neutral and hostile to that signal escaping. The result hints that reionization may have been patchier, earlier, or more locally intense than many models predicted, and it's exactly the kind of evidence that makes JWST such a revolutionary observatory. Closer to home, new kinematic work on the small Magellanic Cloud suggests it is not rotating like a typical orderly galaxy at all, but instead is being tidally stretched along a major axis by gravitational interactions with the large Magellanic Cloud and possibly the Milky Way. That changes how astronomers interpret its structure, its mass, and its history, and it serves as a vivid reminder that dwarf galaxies are not static background objects, but dynamic systems being actively reshaped by their environments. Finally, Earth observation remains a central part of the space story. NASA's MODIS imagery highlighted the Volga River Delta, a complex and ecologically important region where water flow, sediment transport, wetlands, and human land use all intersect. At the program level, NASA is also preparing for the eventual shutdown of its long-serving EOS flagship satellites while extending Stage 3 on the ISS, underscoring how critical continuity is for monitoring ozone, aerosols, climate trends, and the changing systems of our own planet. Thanks to our sponsor, CrispCall. CrispCall provides agentic cloud telephony for modern businesses. Find the link in the episode notes. That's the latest from the Automated Daily Space News Edition. From solar storms to lunar scars to the earliest galaxies, space is becoming more connected, more crowded, and more revealing by the day. Join us next time for another AI-generated roundup of the stories shaping our future in space.